All right. Well, thank you everyone for joining us for February's meetup. I'm extremely honored to have Luca Mezzalera from O'Reilly and AWS talking about demystifying micro-frontends. It's a very interesting topic. I started to look into it a little more as I was preparing, and there's a lot of information out there about how this can really change front-end development. Luca has a number of talks, books, some other material, and actually we're pretty honored to have him. And I'm pretty happy that I will be giving away some books at the end. So at the end of the talk, if everyone can kind of just hang out, and I'm going to pick some random folks and then put out my contact information. So if you get selected, reach out and I can get you a free ebook version of Luca's book. So before we get started, I usually just like to thank our sponsors and give a little bit of information about some upcoming events. So Varen Technologies is a defense contractor specializing in data science, software engineering, big data. If you're interested in learning more, please reach out to me and I can introduce you. ClearEdge is another software development company focused on the IC and Department of Defense. They also do a lot of work with data science, big data, analytics, software development. Again, if you'd like to have more information, feel free to reach out. Areas Ventures is my company. If you'd like to learn more, just reach out to me. I love to schedule a call. I love meeting other engineers. We're also doing data science related activities. So upcoming next month, we have a speaker from Immuta talking about access control. And then I'm working on some of the other talks that are coming up featuring everything from robotics to AI for disabilities. So some really interesting talks coming up. We're still doing the newsletter. We still are always interested in folks that want to speak or attend or be involved in the meetup. You can always reach out to me at info@dataworksmaryland or md.org. And then lastly, we finally are making this happen. So we are doing a conference in June at UMBC. We have basically every speaker set except one. It's going to have talks on everything from ethical AI to machine learning for defense to using satellite imagery. It's going to be a pretty good event. It is going to be in person. We're going to have networking and lunch. So if you're interested in learning more, please check out the website. Right now we're running an early bird special on the tickets, and we also have student discount tickets if you're interested. All right, now I'm about to hand over to Luca. So before I get started, the one thing, if you have any questions, I will be monitoring the chat in both Zoom and for those on YouTube, I'll be watching it there. Just post your question and I will ask that. If you have any questions at the end, I'm either going to ask them during or at the end. So with that, let me do an introduction and I'll hand over to Luca. So Luca is an expert in solution architecture. He is revolutionizing, or he is helping to revolutionize the scalability of front-end architectures with micro front ends. As I said, he has a pretty large web presence. There's a lot of talks, a lot of interesting articles and books that he's written. So if you want to learn a lot more and really deep into it, I would highly recommend looking him up on Google and trying to look at some of his other talks and books. He's currently serves as the principal architect at AWS, and he's helping customers in media and entertainment space deliver cost-effective and scalable cloud solutions. I would highly recommend, as you listen to the talk, kind of start researching a little. It's a really interesting area. You'll find a lot of interesting use cases, and the way that you actually think about the work and break it down is pretty interesting. So with that, Luca, I'm going to stop sharing. You share, and I'll mute myself, and you take it over.
Fantastic. Thank you very much for the presentation introduction. Is this to share? Let me know if you can see it. I believe so. Cool. Fantastic. Okay. Hi, everyone. I hope you are having a good weekend. Sunday morning, I think, for many of you. For me, I'm based in London, so it's a Sunday, almost evening, it was a sunny day in London. That is incredible. So today I'm going to talk about demystifying micro-frontends, and it's a basic introduction to micro-frontends. I'm trying to provide you an idea of what micro-frontends are. In the last 7 years, I work extensively in this with this architecture, and also helped several customers to implement them. And I went through different architecture reviews, evangelization, and many other things regarding MicroFrontends. So I hope you're going to enjoy the talk. So I think Jason did a great introduction about me, so I don't bother to repeat again. So let's start straight to the content. So let's start with the classic implementation. I think everyone, at least once in their career, have implemented a 3-tier software architecture. As you can see here, you can have, in this example, for instance, a single page application as a front-end layer. Then you have in the application layer, the application server, and then the data layer with the database. When we do monolithic architecture, like a 3-tier architecture, the interesting bit is it tends to have certain characteristics. So first of all, we select just one DB technology, usually SQL or NoSQL. It's completely up to you how to handle that. And then on the application server, we have a monolithic code base where all the teams that are belonging on the backend are developing their application. And then finally, on the front end, we have front-end developers that are working all together on the same application. Now, in this case, it's very common that you use a 3-tier application maybe for when you start to have a proof of concept, or you have a startup that wants to validate a business idea. And that is, in my opinion, a very valid option of using a monolithic architecture, because many people are thinking that, oh no, we should go with distributed architecture straight away since the beginning. In reality, I'm a bit against that, because there are some valid points that are the monolithic architecture is bringing on the table. So for instance, you can focus more on the business logic and the features than taking care about the entire system, because when you go to distribute the system, there is a bit of overhead on handling all the different parts in a smooth way. And yes, developers are assigned to a specific portion of the logic, but it's not always easy. So if you start a new business, if you start a new application, this is still a valid architecture, obviously. Then let's imagine now that your architecture, monolithic architecture, raised a lot of success. So the project that you were trying online, maybe subscription software that you are trying online is working, and it has a lot of traction. One thing that usually happens is the business starts to boost a little bit the investment and starts to hire more people. And suddenly, the first thing that they have seen vast majority of the time is that you start to scale the backend. And everyone was focusing on that because, yes, it's true. The backend is quite important. It's providing a lot of value. We start to have maybe different teams tackling different areas of the application, and you move from a monolithic architecture to a distributed one. And sometimes it could be, let's say, a modular monolith. Sometimes it could be a microservices. Sometimes it could be a sales architecture. There are multiple ways to implement that. In this example, for instance, we are moving to a microservice architecture. And the benefit of microservices in this case are the fact that you can easily have a portion of the code. So the cognitive load of your team is definitely smaller than before. Instead of understanding the entire code base end to end and maintaining the same cohesive code base using the same pattern and the same, let's say, tools, you can start to use the right tool for the job. So for instance, you maybe have a microservice that requires a lot of computation. So instead of having Node.js that is single threaded, you can think about a multi-thread language, maybe Rust, Go, whatever. And then instead of using a Unix database, you can start to have your own database that it might be as simple as a cache because your microservice is consuming data from a third-party system, or it could be maybe a NoSQL database that is used for storing a certain part of the information. So as you can see now, the backend developers start to select the right tool for the job. They start to have less things to own, and everything became, to a certain extent, smoother. There are also some additional characteristics. So we have independent services and endpoints, and therefore every team can deploy multiple times per day without coordinating with the rest of the teams. Now, on the front end, however, The problem we faced on the backend is remain as it is. So when you start to scale the front end, unfortunately, vast majority of the time they maintain the same code base. And therefore, there isn't an investment on trying to do exactly the same thing that we have done on the backend, but also on the front end. And that's basically when I started to think about MicroFrontends. 7 years ago, I had the need of taking these monolithic code base on the front end and back end to a distributed architecture, because we started to have quite a few new hires. We moved from 50 to 3,500 people in my previous company. And as you can imagine, the tech department moved from 10 to 500 engineers and QAs in roughly a year and a half, 2 years top. So the growth was massive, and it was impossible to maintain the same code base with all those people, and the ramp up was quite challenging, and therefore we were thinking, okay, so let's try to think differently. Let's try to provide less cognitive load, independent deployment, and all the characteristics that I listed before with microservices on the front end. And that's where MicroFrontends were born. So the first thing that I have done is trying to define what microFrontends are. If you need to explain a concept to someone, you need to figure out what is the definition. So I come up with this definition. So the microFrontends are a technical representation of a business subdomain with independent implementation that they might use same or different technology. And they finally minimize the code share as a distributed system. That is also something that is leveraged in microservices world. And finally, they're owned by a single team. So as you can see here, there are quite a few characteristics that are highlighted in this definition. So now we are going to deep dive into every single of them. First of all, technical representation of a business subdomain. The main difference between a microfrontend and the component is that the microfrontend is looking at the problem from the business perspective, is leveraging basically domain-driven design, is trying to identify what is the portion of the application that is related to a bounded context, like you would do in a microservice world using domain-driven design, and then is trying to represent that part. A component instead is usually way more extensible and leaks the information outside it. So usually the container of a component knows how it has to handle a specific component. That is basically a leak of information or business domain outside the component itself. MicroFrontends usually they try to keep the domain logic inside it themselves. You can still inject certain information, well, as we will see later on, but it's literally very, very light, that part. So the most important thing is that MicroFrontend is, let's say, representing a business subdomain. The second part is independent implementation. That is another key factor of MicroFrontend. So the important thing is that we want to create independent artifacts that can be deployed independently. Every team has its own release cycle. They want to release every day, multiple times per day. They can do that without the need of coordinating with multiple teams. Obviously, that is not always possible. There are in the software development life cycle some moment where you have to coordinate with other teams, but that is more an exception than the regular base. The moment that you find yourself to have two or multiple microfrontends that you deploy always together, probably you need to ask yourself if you slice well the microfrontends, because it could be that in reality you are implementing an anti-pattern that is the distributed monolith, where you have the worst of both worlds. The other thing is microfrontends. If you read online, many people are thinking that is an architecture for embracing multiple UI frameworks. Like I can have an application that is working with React, with Angular, with Vue, with Svelte, and so on and so forth. The reality is the performance matters, and we are not creating a software just for the sake of writing code. We are creating for our users. Therefore, we need to be mindful in the way how we are using technologies. It's very important that we optimize and we maintain our front-end application performance as every user would expect. And that is, for me, key. There are certain situations, however, where having multiple UI framework might be very helpful. I give you an example. For instance, imagine that you are migrating your monolithic code base to MicroFrontends. And your monolithic code base is created with, Angular 2. And then suddenly you decide to move to the same version of the framework, so still Angular, but the newer version, maybe, 9 or 10 or whatever it is. So in that case, for instance, you can, due to the nature of independent implementation or independent artifacts of MicroFrontend, you can start to develop the first few MicroFrontends and deploy alongside the monolithic architecture. And therefore, you are going to create a logic that will allow the user to see for a portion of the application, the new version, and the rest of the application that is still under development, the old version. That basically will allow you to have, for a certain amount of time, multiple, let's say, UI frameworks, so different versions of Angular, so more code to be downloaded by the user, but for a good cause, because you are de-risking the fact that instead of going in stealth mode for 12 months or 18 months before the whole application is ready, you are creating a fast feedback loop, generating value for the customer. It's true there will be some penalization, but that is temporary. It's not going to be for the entire life cycle of your application. The other thing is that that is sometimes controversial. We are trying to minimize the code share. The moment that you have distributed architecture, you need to ask yourself if it's really, really needed to share some code. Because sharing code, it means also having external dependency. And the whole point of dividing in this way the application is because you want to have less and you want to move fast. You want to have team independent and you want to deploy your artifacts as many times as you want without coordination. So if that is true, then sharing code that is changing very often it might be an art. There are certain things that has to be shared, like the design system, for instance, or a login library. Those are things that you really need to share because you want to have a consistent UI in the case of the design system, and you want to have, let's say, the same logs in the same format when you are storing in your cloud provider on the logging example. But in reality, then you need to ask yourself, should I always abstract the code upfront, or should I wait after I see 2, 3, 4, 5 occurrences across multiple MicroFrontends and then review with my teams and decide if it's really needed to abstract the code and create a new library? That's usually a suggestion that they gave, because premature abstraction are definitely more expensive than the duplicated code. Finally, the ownership part. I have seen too many times that front-end developers are taking care about the code that they are writing, they're testing their laptop, and then they are delegating to someone else the deployment of their application. That is not, in my opinion, feasible anymore, especially with MicroFrontends. MicroFrontends should enable developers to own end-to-end the software development lifecycle of their part of the application. They should, a front-end developer or a cross-platform team should take care of building the code and then creating the artifacts, passing through all the different testing stages, then store the artifacts, and then deploy the artifacts. And they should own the end-to-end pipeline, including the observability dashboards that will allow them to understand if the MicroFrontends that they are writing is behaving as expected. And if it's not, roll back or fix the problem. It's important to understand that the ownership is different from contribution. So ownership, it means what I just described, but other teams can contribute to the same MicroFrontend, especially when you have, for instance, a monorepo version of control strategy. And in that case, you can have multiple teams contributing to a MicroFrontend that is not owned by them, But it's important also that the team that is owning that MicroFrontend would be responsible to say, yes, this code should be embedded in this MicroFrontend or not. Because at the end of the day, the ownership, so the team that is owning that MicroFrontend is also responsible for what is going to production. Therefore, if someone else have written some code that they are not comfortable to support, then it might be an issue when they deploy in production and there are some bugs to fix. Then we move to principles, and that is the North Star that are, I think, are important to highlight, because when we are designing MicroFrontends is one of the key things that we need to think about. So first of all, we discussed that MicroFrontends should be modeled around a business domain that we discuss extensively. Then there is another concept, that is the concept of decentralization, that is not only for a technical decentralization, but probably is more an organizational decentralization. What I mean for that is, if the role of the architects, tech leaders, principal engineers before was trying to define, let's say, the common practices across all the teams, now is slightly different. What we are trying to have is more skin on the game from the developers that are working in every team, and having those tech leadership roles that are instead defining the guardrails where the teams are operating. So they define maybe which is the logging library that they're using. They are coordinating the effort for defining the structure of the logs. They are coordinating the effort for the design system, but they are not imposing anymore anything. There are some guardrails, and inside those guardrails, the team should strive. And therefore, we are asking the team to be mindful in the decision that they're making, and also be responsible for them. If they make a decision and then they see that it's not working, they need to recover as fast as possible from that. Obviously, the tech leaders should be there for helping and surfacing also patterns that they feel could be helpful for other teams across the entire community, and therefore creating and organizing community of practices and other let's say events that should basically breaking the silos across the organization is a mandatory thing to do. There is also a culture of automation. Every distributed architecture requires to have a culture of automation. You cannot, let's say, think about many, if sometimes hundreds, if not thousands of MicroFrontends or microservices that are out there, and without investing time on the automation. The automation is key because it's not only a good way to create predictable artifacts, but it's also great for providing a fast feedback loop for developers. The faster is the feedback loop, the more iteration the developers will do, and they will not try to cheat the game. So here it's very, very important that you invest on having minutes instead of, let's say, hours for building your artifacts. And considering the size of a MicroFrontend that is not an entire application, it should be doable. The other thing is independent deployment. We discussed about that. So we really want that MicroFrontends are independent. The other characteristic is hide implementation details. So in microservices, we tend to use API contract for dividing the consumer from the producer. Here should be the same. We should invest in API contract first technique, where we are defining the way how MicroFrontends are communicating together, and then let's say work against those contracts. In these ways, if the contract is respected, you can evolve your MicroFrontend in the way that you want without causing any issue, without coordinating externally. So the contract phase is quite important. It should be taken very seriously, especially at the beginning of the application. Finally, we have a new dimension that on frontend usually we didn't have, is the isolation failure. So it could happen that you have multiple MicroFrontends in the same view, and one of that or multiple of them are not loaded due to network issues. And in that case, how you are going to behave in the page, you need also to think of this, let's say, possibility, because failure is not anymore a binary where you download all the code for an application or not. And if so, only APIs could fail. But in this case, you can have some part of the application that will not be loaded and the other part of the application that is loaded. So you need to understand if the user should see a 404 page or a 500 error, or if the user can still see and use your view and maybe hide gracefully the rest of the microfrontends that are not that important for accomplish a specific task for the user. That obviously, after those principles and guides that I pulled together through the years, I thought, okay, we need more. We need to have some guidance on how we are going to build microfrontends, and therefore I created this framework called the decisions framework that basically is a mental model that will enable you to define the key characteristics of microfrontends. When those key characteristics are nailed, then you can cascade all the other decisions nicely. So there are 4 key decisions that you need to take when you are designing a microfrontends architecture. First, you need to identify what a microfrontend is. Then you need to compose microfrontends. You need to decide how they are going to route and where. And finally, how the microfrontends are communicating together. So on the definition of microfrontend, you have 2 options. Either you have multiple microfrontends in the same view, and that is called horizontal split, or you have one microfrontend loaded per time. The main difference is that obviously, if you have multiple microfrontends in the same view, it means that multiple teams are working in the same view. In the other case, in the vertical split, you have one team associated per microfrontend. I have seen both, let's say, implementation successfully deployed in production. And usually I've seen the horizontal split leveraged by large organizations. And when you have a lot of microfrontends that are repeated across multiple views. So that is one use case of the horizontal split. On the other side, I've seen the vertical split used when you need to have a certain level of control across the UI and the interface, and maybe a very immersive system that you want to give to your user. And also for companies that are starting the journey to microfrontends, because it's very similar to build multiple small single-page applications. There are other things that we need to bear in mind thinking about those 2 options. So with the horizontal split, there is an upfront investment because you need to figure out how the teams are collaborating together. You need to think about their structure. You need to think about who is leading the final output of a view. Because if I have 3 teams working on the same view, who is responsible that everything is working despite there is a new microfrontend that is deployed independently from the others? We need to have, let's say, a team or a pool of people that will be responsible for the final output for the user. There are some testing challenges as well. So for instance, for unit and integration tests, it's not a big deal. We are going to deal in the same way that we are doing right now. But for end-to-end testing, it might be a challenge because now you have one portion of the page that has to be tested, that is your microfrontend, in multiple views. And therefore, you need to be aware of how all the other microfrontends are interacting with and how the user is interacting with your microfrontend. And you need to test all those use cases, or at least the most important ones, in multiple views. And that obviously requires a bit of more effort. There are techniques, for instance, for retrieving portion of the page from stable environments, like your microfrontend is deployed in the test environment, and you are retrieving or fetching the microfrontends out from staging environment in order to make sure that the rest of the page is stable enough and does not causing issues, and you can test in end-to-end your application. There are other teams that other companies that I have seen, they are testing end-to-end directly on production. But in that case, usually it's a dev in test or an additional team that is doing all the key flows for making sure that everything is working, the critical path is working correctly. So there are different techniques that I have seen implemented there, but still it's not an easy task to solve. Then scalability challenges. If you decide to do server-side rendering, then you need to make sure that if you have burst traffic or unpredictable spike of traffic, you are capable to serve all your users creating the right auto scaling in your backend and making sure that everything is working as expected. Therefore, load testing is quite key in this case for making sure that you have an idea of how many requests per second you can have inside your system. And then finally, dependency management. If I have 3 microfrontends from using all of them React, you need to make sure that you're using the same version. You need to make sure that the React is loaded just once and not multiple times, because once again, otherwise you are impacting on performances. And nowadays there are tools and frameworks that allows you to simplify this. For instance, System.js or Module Federation are two of the many that you can use for doing this thing. On the vertical split side is basically building a smaller single page application. Therefore, is way easier to tackle this approach. And that's why I usually suggest vertical split if it's the first time that you are embracing microfrontends. It allows to embrace the JavaScript ecosystem fully. Sometimes, with horizontal split, you might end up that you need to build your own tools for speeding up the developer experience. In this case, it's very unlikely that you don't have to. And finally, I heard several times that SEO is a problem with a single page application. In reality, there are ways to overcome that. There is a functionality that was introduced by Google in 2018 regarding that is called dynamic rendering. And what dynamic rendering does is allowing the crawler to index a static version of your single page application, and then you can have the similar results that you can have with the server-side rendering implementation of your front end. So I highly encourage to look at dynamic rendering if you decide to go with the vertical split. Now, after deciding if you go with horizontal or vertical split, you need to compose your microfrontends. And there are 3 possibilities. The first one is client side. So as you can see here at the bottom, I have an application shell or a container that is basically loading the multiple microfrontends. And the beauty of this approach is basically that you have static assets that are available in the origin system. I usually recommend to have a CDN in order to, let's say, reduce the time for serving the static content and also offload the traffic from origin. CDNs are there for doing exactly that. But moreover, you can also do more in certain CDNs because they are also the first line of defense for any security concern for your static asset and APIs. In this case, you have an application shell that is loading one in the case of vertical split or multiple microfrontends in the case of horizontal split. And that is one way to handle the composition. There is another one that is at the edge side composition. And what happens here is basically you use a markup language called edge side includes that is running in the CDN and is similar to HTML if you think about that. And what it does is you are defining some placeholder. And these placeholders are replaced with the real DOM that then will be assembled and served to the client. So imagine, for instance, you have in the edge side include markup language a cart element. This cart element, or I don't know, payment option, and that payment option will be replaced at runtime with all the elements that are composing the different payment option, like PayPal, credit card, whatever it is. And that might be a microfrontend. The interesting part of this approach is that it's highly cacheable, and it definitely it will provide, let's say, a lot of scalability, because if you think about how many point of presence there are for every CDN provider compared to origin that you can have, usually CDNs are, let's say, way more than origins. So that is a very interesting point. And also, it provides high cacheability out of the box. So you don't have to think about, let's say, caching, headers, and too many things. The problem with this approach is that for static content, it works very well. Dynamic, not that well. In fact, usually it's supplemented with client side included, that there are some JavaScript library available for doing exactly the same thing when you start to have let's say, dynamic content. Imagine, for instance, personalization. If you have a page that is vastly static and then I want to have a portion that is personalized, I cannot do that at a CDN level because I cannot cache it at the end. And what I'm going to do is, if I have true personalization, is rendering on the client side. The other problem with this approach is that edge side include is not available in every CDN. And who is implemented, the provider that is implementing edge side include, they might or might not have implemented the full specification. Today, for instance, Akamai is implementing the full specification of edge side include, mainly because they are the main let's say, company behind the markup language. And also they are providing a decent developer experience. All the others, unfortunately, they are a bit behind. And some cloud providers, some CDN providers are not even providing the capability of edge side include. And then finally, we have on server side composition, where all your microfrontends are composed at your server side. So usually you have, I don't know, if you're working with containers, you have one, let's say, one fleet of containers that is taking care about the UI composition and is calling multiple APIs for retrieving a template and filling basically the composition of microfrontend and serving the final page to the customer. Also, in this case, a CDN is recommended because then you can cache certain portion of the page. Obviously, here you can also use an isomorphic architecture where you have some code that is running on the server and on the client. And what you're doing is, when it's running on the client, is hydrating the code for adding, let's say, user interaction, or if you want to have API calls on the client side for offloading, let's say, the computation on the server side, you can do that as well. After composing, you need to route. And when you have a client-side composition, the routing is happening on the client side. For certain CDN, you can also use a bit of computation on the edge. So for instance, in CloudFront in AWS, you have the possibility to run a Lambda at the edge. And that is basically a container that is close to the point of presence of the CDN. And then you can run some logic before it hits origin. That basically will allow you to, for instance, select a specific, if you are migrating from a monolithic architecture to a MicroFrontends one, you can, instead of adding the logic on the client side, you can add the logic at the edge, and then that basically will serve the right artifacts to the client, either the monolithic architecture or the MicroFrontends one. In the case of edge side include, the routing is happening on the CDN level. So every URL will have a set of microfrontends that will be loaded, and the same is happening on the server side composition. So the routing is happening at the server side, where the application server, or better, the UI composer layer, knows how to handle that part. Then finally, we go with the communication part. That is the fourth element of the system, the fourth decision. So when you have horizontal split, so multiple microfrontends in the same page, usually you tend to use a publish-subscribe pattern. Why that? Because a publish-subscribe pattern is decoupling the producer from the consumer, so you can have how many consumer you want, and the producer doesn't have to know. The only thing that the producer knows is that he's going to emit some events and someone will pick it up. But then what happens after is not his concern. That basically will allow you to maintain this segregation between microfrontends, and you don't have to share global state or any other thing that then will risk to couple your microfrontends all together. So event emitter, custom events, reactive streams, all of these are techniques that will basically allow you to embrace this pub-sub pattern. And either you work with vertical or horizontal split, you need to deal with sessions or session tokens. And in that case, usually for session tokens, you can use cookies and local storage. All the microfrontends can access those two web storage available on your browser. So by convention, you say when the user is authenticated, just go and retrieve from the cookie and send to the information that you need and send to the APIs in order to consume them. Instead, if you have ephemeral data, like for instance, an ID for a specific product selected by the user that you need to pass to the next view, you can use query strings. So in that case, by convention, you know that the MicroFrontends will need to retrieve from the query strings the ID that is needed to fetch the information for a specific product, and that will work out of the box. So now I want to end up this presentation with an implementation. So just to show you how you would reason when you are implementing MicroFrontends. So this one is a vertical split architecture because, as I said before, I think is a good starting point if you want to embrace MicroFrontends. So in this case, what you have here is the holy trinity of front-end development. So you have HTML, JavaScript, and CSS. Those three things are the most common things for any front-end developer. And they are used to work with that. They are dealing with that every day. So it's not a problem at all. And that is also how you can interpret a MicroFrontend. The interesting part is when you have a MicroFrontend that has as entry point an HTML page, it means that you can load an HTML inside an application shell. The application shell, what it is basically, once again, HTML and JavaScript and a bit of CSS. And what it does is, first of all, loading a MicroFrontend. The entry point is an HTML. And but the HTML at the end is just an XML schema with a specific, an XML with a specific schema. And therefore, you can parse it easily with JavaScript and append the node that are signed inside the HTML into the application shell. So basically, the moment that you are appending all the DOM elements inside the application shell, as well as the script tag and the CSS link, automatically the browser will start to load the other resources. And the beauty of this approach is that the HTML can be, let's say, rendered upfront. You can create a skeleton that will be loaded upfront to the user so they can start to see the page build, also if not all the data are there yet. And that is a very nice user experience because the users start to see more information before the whole page is loaded. So you hydrate the page before everything is loaded. And that is a great way to handle these things. You can also bypass the HTML and have as a starting point or entry point for every MicroFrontend some JavaScript code. But in that case, obviously, you need to wait that the engine inside the JavaScript engine inside the browser is loading the code, parsing it, creating in memory variables, start to create a virtual DOM if you're using a library with virtual DOM, and then finally render inside the DOM. So that could take quite a few milliseconds, if not sometimes seconds in very complex pages. The responsibility of the application shell in this case is obviously loading the MicroFrontend. So we set a vertical split, therefore one MicroFrontend per time. And then is also responsible for the routing part. So the logic for going from one MicroFrontend to another one based on the URL that the user is selecting is the application shell that should be aware of that and knows which MicroFrontend to load. On the other side, is also responsible for the MicroFrontends communication. One technique that I have seen implemented in some of my customers is creating a tiny layer between the local storage or cookie and the MicroFrontends in order to also make some checks. Usually in this tiny layer, they say, okay, if you are the authentication MicroFrontend, you can only write inside the local storage. But if you are a catalog, you cannot write, you can only read from the application storage. And in this way, you can also provide enforcement on the capabilities that every MicroFrontend is doing. On the other side is also providing some MicroFrontend lifecycle. So every MicroFrontend should have, in this case, the unload function that is a callback that is called by the application shell when the MicroFrontend is about to be unloaded. That method will allow the MicroFrontend to remove all the listeners that are pending inside the application, and also to remove any other library or memory thing that they have created in order to have a fast garbage collection for the memory. So in this case, you will make sure that there won't be clashes when new MicroFrontends are loaded. And then finally, sharing initial configuration. The application shall, because should be domain unaware, shouldn't have any concept of, let's say, business domain. It can also load a configuration that is providing a set of information to the MicroFrontends that maybe are spun across all of them. So for instance, it could be, I don't know, the endpoints to consume for the APIs that maybe are external, some feature flags, stuff like that. So the vertical split has different strengths. So first of all, the developer experience is very similar to a single page application. So developers are very familiar with that. They don't have to reinvent the wheel. It's easier to identify business domains because it's very coarse grained. So you can say, I have, I don't know, the landing page MicroFrontend, I have the authentication MicroFrontend, I have the catalog MicroFrontend. As you can see, I create 3 bunches, but now it's easier to develop and deploy them independently because you don't have to, let's say, go too granular upfront like you would do with the horizontal split. It's highly cacheable as artifact because you can store, as we said, in an application server, and I have a CDN where you can tweak the headers for storing into the cache for how many weeks, days, months, years that you want. And then also allows you to work very well with the strangler pattern. So the possibility to basically migrate from a single page application to this new MicroFrontends application is easy because you already have a portion of the page that is developed. And when it's ready, you can easily migrate portion of the application to the new implementation and the rest with the old one. You have great UX control by the team because obviously you don't have to coordinate across the team. One team is responsible for one MicroFrontend, and therefore it makes easier to reason and develop the MicroFrontend. And easier to testing also because the end-to-end integration, so unit integration test is easy, but end-to-end testing in this case is literally touching the border. So how I can load the MicroFrontend and testing that scenario, and how you are unloading the MicroFrontend in favor of something else and testing that scenario. So I don't have to, let's say, know everything about the application. I just need to know what are the neighbors link that I need to load. Obviously, it's not everything easy with MicroFrontends. As every architecture, you have trade-offs. So there are some challenges. First of all, is automation. If you need to have a culture of automation, as we said before, but at the same time, you need to create this culture. So you need to foster and explain developers why they need to invest in that. And that is something that sometimes in certain organization is complicated. And also you need to ramp up the skills on understanding maybe how containers work, how I don't know, certain tools that for building artifacts are created, and so on and so forth. So there is some challenges over there. Observability is another key one. So when we have distributed system, is mandatory, in my opinion, having some observability libraries and tools that allows to immediately spot when there is an issue in production and understand where the issue is happening. And when you have a distributed system, this is, let's say, a requirement. I would say that is one of the key things that you need to set up upfront. So every team has its own dashboard that can understand deeply what is the problem and where it is and fix as fast as possible. Code sharing, it might be a challenge, as we said before, because you need to really wait when a MicroFrontend is using external dependency or not, and you need to understand if the right call or not. My suggestion is, before starting immediately with an abstraction and having external dependency, is always better wait a bit, and then you are going to iterate later on to see if that code duplicated maybe 2 or 3 times require really an abstraction or not. Design system, the suggestion I have there is using web components, mainly because web components are framework agnostic. So you can use them with any framework. And if tomorrow you're going to change the framework, web components, that is the first investment that you're going to make, is going to be there. And you don't have to, let's say, rebuild from scratch the entire application. Don't hold yourself on performance. It's very important that you are going to invest on performance as well. Every tips and tricks that you have for single page applications or side rendering are also applicable for MicroFrontends. There is another interesting thing when we are talking about client-side rendering microfrontends. So compared to a single page application, you are loading a portion of the code, and therefore it's very likely that upfront you're going to have some benefits in the amount of kilobytes that you are downloading. So use that for optimizing even further. So maybe imagine, for instance, if I'm in an authenticated area and I don't have to subscribe to a service or whatever it is, it's very likely that I'm not going to download the SDK for credit cards and the SDK for PayPal and any other payment methods you have. So you are saving sometimes tens, sometimes hundreds of kilobytes that the user are not going to use in that case. So leverage that thing and optimize even further. And finally, don't be afraid to change the organization structure. Bear in mind that organization structure should be fluid as the business is. The business is evolving, the architecture is evolving, therefore the organization structure has to evolve as well. I would like to leave you with this thing that has to be very clear. What I presented today is some architecture that represents some trade-off. And architecture is not right and wrong. It's based on trade-offs. So you need to understand your context and find the right approach for your context. That will allow you to leverage the benefits of the architecture and not being too penalized from the trade-off that you need to make. We share the slides later on, and here you can find, let's say, a few links if you want to start in the journey into MicroFrontends. There are an article about that I wrote for an American magazine called Increment about the decision framework that I described briefly before. Then the link to my book and another book on MicroFrontends. And then a few videos that I have on YouTube available for you. And the last one is a research that was made by a Finnish university regarding MicroFrontends that I helped to review, and I provide some insight for them. That's all I got today. More than happy to answer some questions. If you have questions, I don't know, next week or later today, feel free to reach me out via email. Thank you very much.
Thank you, Luca. I did have some questions, and folks in the audience, if you want to start typing questions, I'll capture them. So it seems like there's a large dependency on making sure the teams work well together. I guess my question is there like hints, like, are you applying like Agile and Scrum like processes on top of that to make sure that the teams are in sync?
But usually, when you work with MicroFrontends, as I said, if you work with them right, you have independent artifacts. So the synchronization is, let's say, very light. When it happens, usually what I've seen working very well is a sort of Scrum of Scrum, where you have like one team member for the team that they need to work together. They catch up regularly every other day or every week. Just to make sure that they are in sync.
Okay, that makes sense. So you started talking about like the vertical and horizontal split. So is the idea that you start in the vertical split and you eventually transition to the horizontal split?
Yeah, that is one thing that I have seen. Sometimes I've seen companies starting straight with the horizontal split because it was very clear what they wanted to build. And the other thing I have seen companies that are using both in the same project. And a classic example that I used to make is, imagine that you have vertical split for vast majority of the application, but that suddenly you have a new requirement like my account that includes user data, payments information, maybe some settings of the application, stuff like that. Those are free domains that you want to expose in the same view. So in that case, you have three teams working together, and therefore you can have in certain areas some horizontal split MicroFrontends.
Okay. Now this question might be showing my my lack of understanding in a lot of this microservice and micro-frontend, but working at AWS, are there like services that AWS provides to make this easier to do? There was a question about how AWS allows multiple login libraries. So I guess I'm trying to see is there things that AWS has built in that makes the design and development of micro-frontends easier?
At the moment, no. Currently, I'm working on creating some reference architecture that will allow to provide some, let's say, ideas on how to use AWS services in conjunction with MicroFrontends. For client-side rendering, I would say is fairly easy. The infrastructure you need to put in place. But for a server-side rendering application, it's definitely more complex. There are multiple options that you can leverage. So I'm trying to focus first on the server-side rendering approach because that is the most complex one, and then let's say create another reference architecture for the client-side rendering approach.
I saw references to MicroFrontends starting around 2019. I don't know if that's around the time when they started to get some popularity. Yeah. Are they growing in popularity, or are they becoming more and more common?
Definitely. Currently, there are quite a few organizations that are implementing this pattern. Recently, PayPal started to use them, American Express. Before there was IKEA, Microsoft, Starbucks, Fever, if you know the service, and a few others. So that there are Netflix even started to use them for an internal tool. I know that they are currently thinking about, let's say, for other parts, but more or less every large organization or enterprise organization that is starting to let's say, scale their front-end development, they are looking into them.
So I know, like with Docker and Kubernetes and all those technologies, it kind of really built up almost like a new role in the whole software development, team, right? With DevOps and things like that. Are people becoming specialists in deploying and designing and working with, other than yourself, of course, but is there like a role in each of these teams to understand? Because it seems like it could be very complicated, all the tools and how you deploy it and how you get everything integrated.
But if you think about the, let's say, a microservice, for instance, what you usually do in that case, you have a team that is responsible end-to-end of that microservice. So we are just shifting that paradigm to the front end. So the front-end developer should definitely know a bit of DevOps, a bit of infrastructure, but I don't think is impossible, because we are reducing drastically the amount of cognitive load on the business domain because they have just a portion, so they can supplement their technical skills with additional things. And full stack developers, for instance, they are already doing that. Probably they need to go a bit more in deep, but considering that large enterprises have already started this process, I don't see the problem of let's say extending that also for other developers. The thing that definitely that I think you were right in the previous question regarding how we can facilitate the developer experience is something that we need to look at as a community, not only as AWS, more in general as a community, how we can simplify this process, how we can how can we streamline this thing. And I believe it's totally doable. But obviously, if with microservices, we are still there figuring out a few details, I think also with MicroFrontends, it will take time, because we need to reach a level of maturity as a community that will allow us to say, those are the things that we need to work on, and start to work on those.
So there's a question about comparing MicroFrontends to microservices, and I'm going to do the best I can to ask the question. It was really like, why not just move, I guess, the functionality directly into the microservices? And I tried to ask a follow-up, like to try to understand what the asker or the person asking the question meant. And they said that the way they understand microfrontends is that they are separate containers with only the needed front-end code associated with another microservice in the same domain. I'm not sure if that question makes sense, but
yeah, it does. Potentially, there are companies that are doing that. There is an Italian company called Mia Platform that is doing something similar. The thing is, you tend to decouple the front end with the backend infrastructure, mainly because if something fails, maybe it's just one of the two that is failing. Otherwise, it's, let's say, completely failing. You can argue that because are coupled, they should be always live together. It could be a possibility, but sometimes you might imagine that if, for instance, you have content that is highly cacheable and that you cannot retrieve the data from the microservice, and therefore the MicroFrontend can use stale data. So in a scenario like this, for instance, the fact that they're decoupled is very useful. In the case that you have instead everything coupled, if one of the two parts are not responding, everything is down.
Okay. I'm trying to keep up with the questions now. They're kind of flying. How can micro-frontends work with the Jamstack approach?
Yeah, so Jamstack usually you are composing at compile time. You can potentially do that. The only thing is that the composition layer has to happen at your CI, and then you are multiple teams basically are contributing to these independent elements, and then you are composing at the CI, and then off you go. You have your static page that can be built. I have to be honest, I didn't see many implementation of MicroFrontends with Jamstack, but I don't see why not. Technically speaking, it's doable.
Okay, the same member asked the question. I wasn't able to Google this one. I was looking up Jamstack to try to understand it, but he said, can edge workers help with getting more dynamic content in place of ESI?
Yes, so edge workers are definitely very interesting. I think currently there are a few companies that are allowing you to run some code towards the edge. The main challenge, in my opinion, is trying to figure out how everything will work in complex applications, because in reality you don't need only computation, you need also authentication, authorization, you need let's say retrieval of data, caching of data. There are, let's say, quite a few other characteristics in architecture that currently, vast majority of the time, we are focusing only on the computation side. For simple website, yes, it could work, but that is, let's say, is a part of the ecosystem. There are also more complex websites where having at the edge the computation, it will work for rendering the page, but in reality, you need to go on the origin for retrieving certain information.
Cool. He said, thank you. So there was a question about UX design and like, how does that work across micro front ends? Do you kind of have agreements across the teams on what that general design is? And is there like a UX design team that's above the teams responsible for the micro front end portions?
Yeah, so usually for the design, if you have a design system, it's easier because you provide a library to the developers and provide obviously some artifacts to show them how the page would look like, and then the developers will use the right components for the view that they need to build. Usually, what I suggest, if you don't have a design system, at least work with design tokens. Design tokens at the end are just JSON files that are describing, let's say, the hexadecimal color of an element, the font, the size of the font, a few other primitives that will allow the developers at least to be coherent across the entire system. Remember, you have a distributed system. So it's very important that you have, let's say, a way that you maintain in sync the different microfrontends. Now, there are some teams that I have seen, they require by the business to have every microfrontend with the latest version of the, let's say, design system up to date. Some others that they are more flexible. So they say, if I version a design system with the same verse, so having major, minor bug fixing, I ask the teams to be in sync with the major version, but the other two can be up to them. That will basically provide a bit of slack to the developers to, let's say, fix or update the latest version of the design system when they have time. But there are others that they require strong consistency. And in that case, my suggestion is intervene at the CI level. So a continuous integration pipeline, basically what you can do is inspecting the JSON file associated to every microfrontend and check the version of the design system. If it's the latest version, great, you allow to build the artifact. If not, you basically trigger an error and notify the team that they need to upgrade the library before to build the new microfrontends.
That was great. So if anyone has any following questions, please type them now. But my last question would be, uh, and you could say your book. How would you get started in this area? Is it really starting with the demystifying book that you wrote? Is there other resources to get started?
I think online you can find quite a lot. I would say, obviously, it's not. You can find quite a few things. Depends how you learn. For instance, a person that likes to learn the mental model first and then start to apply. Other people, they prefer to write code and learn from there. So you can either start creating a small proof of concept or a demo and see how the things are working. There are some frameworks out there that would allow you to speed up the development of your application. If you want to understand, let's say, the different possibilities, in my book, I spent like 2 years for writing and research the different parts on top of the experience that they have consulting different customers worldwide and building MicroFrontends, not only for web, but also for living room devices. So there are a lot of information there, but there are also other books that are available that you can buy, and they are, I read them, and equally, let's say, great as content that you can find over there. So overall, there is, let's say, the best way. And then if you prefer videos, if you go to YouTube, you can find gazillions of video MicroFrontends, really. So there is really a lot out there. There are also communities. For instance, there is a Slack channel of MicroFrontends that is available. I created a Twitter community. If you search MicroFrontend in the Twitter community, you can find there. There are already a few hundreds of people that you can ask questions, and it's very likely that they are going to answer. So that is basically the ecosystem, the community. But I think we will have more and more information in the next few years when more companies are learning how to implement them and start to share their learnings with the community.
That's great. So the last question, this is something that I was actually feeling also, but it was asked, so I might as well ask it. There's, as you introduce microservices, micro-frontends, it gets very complicated, complex. Like, what are your suggestions for organizations and individuals to kind of be able to track everything to keep it? And you mentioned one, and maybe that's where you're going to go. Like you said, you really understand the mental model. Like, do you have recommendations on how you think about the problems and track all these different technologies and architectures?
There are a set of tools, I would say, or mechanisms that are helpful in this kind of situation. You can start from architectural decision record, where you are mapping or having a snapshot on when you have to take a decision. Architecturally speaking, you list basically in this architectural decision record what are the options and why you selected the specific element. And then every time that someone is asking why we are going that direction, you can show the analysis and provide the information. And that obviously can be revised every few months or every year, whatever you want. Having requests for comments is another common method for keeping track of these things, because the reality is, I agree. So the information can be spread across the team. So you need to create some mechanism that will allow the team to document what's happening and having some snapshot in time to understand when there are key decisions happening. And then, in my opinion, those are usually the best way. Unfortunately, when you do meetings, yes, you can quickly find an agreement, but in reality, unless you document after the meeting what you discuss, is very unlikely. What I learned in the hard way, if you want, in the trenches, was that if you write a document, you have to think clearly of what is the problem, what are the options, and you need to express your ideas to someone else. And therefore, you are making an extra effort for being clear. And that is probably the best investment of time that you can have for keeping everyone in sync. But then also meeting like community of practices, town halls, or office hours. It could be, let's say, that, for instance, I organize an office hour every month, where developers can join and ask questions, and everyone were there, and where we were discussing specific topics. And when I found something, let's say, juicy, that maybe we need to go more in depth, I basically take the time to revise that, understanding better the problem, and then sharing again in the next office hour or community of practice, or organizing an ad hoc meeting. So the thing is, it's very important to understand how your company is structured and provide the right mechanism that basically is facilitating the spread of these informations.
There was one question that was snuck in, and I'm actually kind of curious. Any tools like system.js you recommend to bring all microservices together?
Module Federation, that is a Webpack plugin, is one. System.js is another one. There are plenty of other frameworks like Puzzle.js. There is Holocron from Amex. There is how's called the other one? Oh God, I forgot it. Podium, that is another framework for doing server-side rendering and client-side rendering. So there are plenty of frameworks. If you search online, MicroFrontends framework, you can find plenty of them. I honestly, I struggle to say you need to start with, because the real problem is you need to understand what problems you are trying to solve. Then based on that, you will filter out which is the right framework.
That's always the problem, right? Whenever you read like Hacker News, it's like, what do I use? And it's always like 1,000 options.
To be honest, sometimes I think there is this unfortunate hype-driven development, as I call it, where people are taking just the latest hype and they start to use that, and maybe they don't have to use that because it's not fitting the purpose. But my suggestion is always try to understand the context, and then you work backwards to find the solution that you need.
That's good. All right. Well, I think we're going to wrap it up. Luca, that was awesome. That was a really good talk. It's a very interesting, it's a very interesting thing, and very complicated. I was trying to keep up with you, honestly, and Googling as I was going. And the good thing is there's a lot of resources. So a lot of the stuff that Luca talked about, he has in Medium article posts. I posted one, other talks. So this is definitely an area where you can learn a lot by following the things that Luca is working on. Luca, I'm guessing if people want to get in touch with you, they can kind of reach out through your website. Is that
absolutely via email or on socials? I'm very active. I love engaging with people, so feel free to contact me anytime, and don't worry, I will reply definitely in 24 hours. I'm a self-taught, therefore I know the importance of the community, so I'm trying to be as much present as possible. I had the opportunity to see this revolution, if you want, firsthand. So I really like, let's say, chatting with people, discussing, seeing the challenges, trying to provide my take on them, and so on and so forth.
Awesome. So I'm going to give away a couple books real quick. If I call your name, I'm going to post my email real quick, and then if I call your name, just shoot me a quick email, and I will make sure you get a ebook version of Luca's book.